So finally, in topic 3, we have these two tools in addition to the one we just covered: scale economies and learning effects. So let's go ahead and dive into scale economies. Scale economies are cost advantages that come with large scale production. And some of these cost advantages are efficiencies that tend to improve as scale increases. Suppliers can spread fixed costs over a large number of products, which justifies hiring more highly skilled workers and improve training programs. And labor efficiency improves and cost of labor goes down per unit. All of these are benefits of having larger scale production. So let's dive into the learning curve. So the labor content matters. The more labor intensive the process, the greater the opportunity to lower costs through learning. So if it's an assembly line or a heavily, let's say, manual labor, the learning curve can be dramatic. Where if it's more not labor intensive, then it's not going to be as effective. And complexity matters. The more complex the process, the greater the opportunity to learn. So our learning curve is going to take on a different shape. And diminishing returns exist. That law of diminishing returns. Most of the learning takes place early in the effort. So we'll have a dramatic curve right in the beginning, and then it will tend to level out. So how do we analyze this? Well, we have a formula. So our formula is T sub n equals T sub 1 n to the power of b. And that's where the T sub n is the time required to produce the nth unit. And then T sub 1 is the time required to produce that first unit. N is the cumulative number of units to be produced. And then B is the natural log, which is our rate of learning, divided by the natural log of 2, which is the rate with the rate of learning expressed as a decimal. And your decimal is going to be a negative number. So let's go ahead and take a look at a chart here. So learning impacts cost. So when we compare Japan and the United States in the early 1980s, when we do cost per unit and then volume per model, we had the United States with a 90% learning curve. And you see how that is not a dramatic curve. It's kind of a slight downslope, almost through the entire graph. But then we have Japan, which had a 70% learning curve, when the United States had a 90% learning curve. They had a huge dramatic drop early in the process. And then it leveled out, that diminishing return. So what it can tell us here, that Japan didn't need to make a whole lot to get the benefits of a learning curve. With the United States, we needed quite a bit longer to get a benefit out of the learning curve. Now, to make this curve, we would take that formula and actually plug some numbers in. So let's do an example here. So our example is, every time your supplier doubles production, the supplier reduces labor content by 20%. The supplier's learning rate is 20%. The process would be said to be operating at an 80% learning curve. So you have 100% minus 20 equals 80%. If the first unit produced required 148.96 hours, the second unit will require 119.17 hours. So that's 0.8 times 148.96 equals 119.17. The fourth unit produced, remember, we're doubling. Every time your supplier doubles production. So that's 1, 2, 4, 8, and so on. So the fourth unit produced will require 95.33 hours. So that's 0.8 times the 119.17 and that's going to equal that 95.33. So that 119 was from the 2 units. Remember the doubling that our supplier is doing. So how much time would it take to produce that 250th unit? Or how much time would be required for the 250th unit? So if we have our formula here, first we need to figure out B. Remember, that's the natural log of our learning curve, which is 80%, divided by the natural log of 2. So that's natural log of 0.8 divided by natural log of 2, which equals a negative 0.3219. So you want to be that specific. You want to go at least 4 decimal points. So let's insert the facts that we know. So we have our T sub n. So we want to know what our 250th unit is. So that's T sub 250. We know that first unit, which is the T sub n, is 148.96. And then we want to multiply that by n, because we want to know what the nth unit is. That's 250. We take that to the power of b, which we came up with a negative 0.3219. So let's get rid of that power. So it's going to come out to 0.1691. We're going to multiply that by 148.96, which is going to give us our final answer of 25.18 hours. So when we get, it's going to take 25.18 hours to go from our 249th unit to our 250th unit. That's a pretty good difference when we look at it took 148, let's just say 149 hours for our first unit, and our 250th unit is taking roughly 25 hours to complete. So that's a learning curve. That's how we figure out that. And this is very helpful when we're trying to figure out what our production speed is when we're X number of units in. We can figure out what our learning curve is. So by factoring all these, using all these tools, it can greatly help us be more competitive and meet our customer need in the market.